Hi everyone, welcome again to another video of SAT Math Explained. Today our topic will be about inference from sample statistics and margin of error, which is within the problem solving and data analysis domain. Um, so after this there's going to be one more video for problem solving and data analysis. Then we're going to move on to the geometry domain, where we have 4 videos there, and then that will be it for SAT Math Explained. However, if you guys have any videos that you want to, like any extra topics you want me to go in depth more, like let's say you want help with factoring or something, just let me know and I'll make sure to upload a video. And so let's just get straight into it. So first thing, what do you need to know to answer these questions? One important thing is margin of error. I think almost every SAT will have one question where almost every SAT, like for me, every single one, you'll have a question where you can literally just solve it by just knowing margin of error. You can solve it in 5 seconds with it. If you don't know margin of error, you won't be able to solve it. So what is margin of error? Margin of error is basically just a statistic which tells you how much the actual data value can vary. So an example would be, just a quick example. Let's say that you surveyed a school, surveyed 20 students about if they played sports. So then you say that I have, okay, so I got 10 10 students play sports with a margin error. Sorry. So let's say you have a margin error and you say 10 students play sports with a margin error of plus or minus 2. So that means the actual possible values of people who play sports is actually 8 to 12. Because let's say you that's the mean between 4 different schools or something. I don't know. It's gonna make sense. If this doesn't make sense now, there's gonna be an example later on, and it'll make more sense. Another thing you need to know is confidence interval, which is basically hand in hand in margin error. What is the possible values based on the data set and based on the margin of error, and what values are possible, which values are not. There are going to be some questions just asking you to maybe infer, like make a conclusion based on the data, something like that. There was like a couple questions for some reason on the question bank, just ask. It was basically just asking what is X% of Y, basically, and X or Y are constants, if that's not clear. So just know, like just not know, but recall percentages. There was a video about it like 3 or 4 days ago. Just recall percentages so that because it will show up and it's good to know. And I mean, you could technically choose to use percentages or ratios or fractions, whatever you feel, or decimals even, whatever you really feel more comfortable with. And then one of the biggest topic is amplifying data. Many questions will be basically like, let's use the same example of the margin of error. So let's say you surveyed the 20 students, you got that 10 of them played sports. From there, you want to generalize that or amplify the data to fit the 1,000 students. So if you had 10 out of 20, you could either say, okay, you could either say there's 50%, you could say the fraction 10 over 20, and then you would multiply that by 1,000 to find the number of students, to estimate, not find, to estimate the number of students from the whole school who play sports. So yeah, so then the margin of error would most likely apply to the amplification, not necessarily the 10 people out of 20, because there's no margin of error. 10 people out of 20 said they play sports. I wasn't clear about that. The margin of error would apply to the estimate more, not to the original data values. And it'll make sense with the examples. So how do you solve these type of questions? First thing, identify the information given. What did they give you statistics? Did they give you margin of error? There are a couple of questions that will give you like a chart or a diagram, and you not that yeah chart, and you'll have to like get the information from there. And what do they want from you? Do they want you to infer something? Do you want or conclude, or do you want sorry? Do they want you to infer something? Do they want you to conclude something? Do they want you to make a generalization? What do they want from you? Use the information to most likely it's going to be infer, conclude something, generalize a statistic, and there's also the margin of error questions. And then just sometimes apply previous skills. For this one, I don't think there's for the other ones applying previous skills most of the time would just mean no algebra. For this one, it's actually more of like previous previous topics in the problem solving and data analysis domain. So things like know what mean is, know percentages, ratios, stuff like that. So it's important to know those before you watch this video. So if you haven't, go back and watch those. Examples. Yeah. So now we're going to move on to examples. As usual, I like to reiterate this. Make sure that you try the examples on your own first, and then watch my explanation, because just watching the explanation will make you feel like you understand, but it's just a false feeling. And on test day, that won't help you and will be harmful. And as usual, we're going to do two easy questions, two medium questions, and a single hard question. So let's start with the two easy. So this one says a city has 50 city council members. Here's something to just watch out for. Almost every single time they start with just giving you like the total number. It's going to be a question asking you to amplify the data. And here's something I forgot to point out in the how to solve. For the previous topics and everything, I kept saying to always skip over the question, just read the last sentence. For this one, it's not like a long scenario. Honestly, everything is going to help you. Like every sentence is going to have information you're going to need to answer. So for questions like these, try to just skim through it. So okay, so the total is 50 city council members. They polled a random sample of 20 of them. 6 of them support a specific bill. Based on the sample, best estimate of the number of city council members who support the bill. So here, like I said, you could either use a ratio, you could use a fraction, you could use percentage, you could use decimals. It's all depending on what you prefer. So basically, we're going to try to amplify the data from the 20 people sampled. We're going to amplify it so that we can generalize it make an estimation that will generalize how many people from the total 50 city council members support the bill. So you start by finding the fraction or percentage or decimal ratio who support the bill from the from the sample size. So you could do 6/20. You could say that it is 30%. You could say that it is 0.3. You could say that is if you want for some reason you could say I want a ratio. Just put a ratio, I guess. And then it's the same thing for that. To generalize it with the 50 city council members, you're just gonna do 50 times one of these. You choose which one you want. So I'm just gonna show you guys in Desmos. Um, so you have the 50 total. So you have 50 multiplied by. So you could do 6/20. That gives you 15. 50 times zero point 0.3, 15. You could do 30% of 50. You get 15. I don't know how ratios work. So for ratios, you would actually just convert it to a fraction. You have to convert, if you have a ratio, you'll have to convert it to one of these. So the ratio is not actually going to be helpful here. And then from here, you see they all give you the answer of 15. So, and that is answer option C. Okay, so now let's move on to the next question. The next question tells us that a certain forest is 253 acres. So similar to the last one, if it tells you the total in the beginning, you can always assume it's going to be amplifying the data question. So to estimate the number of trees in the forest, he selected 5 different 1 acre parcels. So he did a sample size on 5 different, let's say, 1 acre, 1 acre pieces, 1 acre squares, let's say, to determine the number of trees in each parcel. The number of trees were as follows. Were the number of trees in each acre were these number 51, 59, 45, and so on. Then it tells us based on the mean. So we're going to mean. Remember, you have to recall that it is the average. So average. So if mean is the average of the sample, which of the following ranges contains the best estimate for the number of trees in the entire forest? So basically what we have to do, you have to find the mean. And because we have 5 different data points, we're going to first find the mean and then amplify it to the 253 acres. From there, we want to see within what range is the best estimate. So basically, the answer options give a margin of error. You're not asked to find this, you're asked to find the estimate and determine which one it falls within. So how do we do this? First thing, start by finding the mean. So just open Desmos. And okay. So the mean, you could technically add them and divide them all. Add all the number of trees and divide them. But a quicker way would just be to use Desmos. Just put mean and list the numbers. So 51, 59, 45, 52, and 73. And so you know that the mean is 56. So the mean is 56. From there, what can you do? What do we need to do? You need to amplify, amplify. I think that's the best word to use. Amplify the 56 trees per 1 acre You want to amplify it so you can generalize it to the whole forest. So multiply that by 253. So 56 times 253. So our estimate based on amplifying the mean is that there is 168 trees. 14,168 trees in the forest. And that is an estimate. So because it's an estimate, it's going to have a margin of error. We don't have to calculate that or anything. We just have to find within what range does it fall. 14,168 falls within the range seen in C of 13,500 to 14,500. So that is the answer. So that's how you solve that. Again, if you ever have any questions, let me know in the comments if anything's confusing you or something, or if I say something confusing or I make a mistake. I was supposed to be a V. Anyways, so now that's it for the easy questions. Let's move on to the medium. So this one, a random sample of fish were caught and marked in order to ensure that none were weighed more than once. These sample contain, so they made a sample on 150 largemouth bass. 30% of them weighed more than 2 pounds. Which of the following conclusions is best supported by the data? So here's one of the infer or conclude something based on the data question. And so for this one, you guys could see the first two sentences were basically meaningless. But basically, the first one, so we're just gonna have to read each one and determine which one is best supported. You might have two of them that seem supported, but you have to find the one that is best. So the first one says that the majority of all fish in the pond weigh less than 2 pounds. So this might seem like it makes sense, right? Because we're told that 30% weigh more than 2 pounds. So that would mean 70% weigh less than 2 pounds. But you have to pay attention to the question. It says 150 largemouth bass. So that is a specific species of fish in the lake. This conclusion is generalizing it to all fish. So it might be right if the other options aren't good enough, but it is a bold generalization and most likely will not be right. But let's just move on before canceling out. This one says that the average weight of all fish in the pond is approximately 2 pounds. So this is, you have to recall how averages work. So it says that they're approximately 2 pounds. Again, this one is talking about fish in general instead of largemouth bass. And at the same time, 30% weighed more than 2 pounds. That doesn't mean that the average is going to be around 2 pounds. That 30%, they could all weigh 10 pounds, and the average is going to be skewed to the right to, like, let's say around 6 or something. So it can't be that we can't guarantee. So it might be, but we can't guarantee that the average rate will be 2 pounds. And it also generalizes it to all fish and not just that specific species. C says that approximately 30% of all fish in the pond weigh more than 2 pounds. Again, this is the same thing as A. It might be right, but it's basically just generalizing the. It's basically generalizing the data to the sample size and the data to all fish in the pond. And also something else to see on the SAT, if two answers basically mean the same thing, you know that neither of them are right. So this one says that the majority of all fish in the pond weigh less than 2 pounds. This one says 30% of all fish in the pond weigh more than 2 pounds. So they're basically just doing the exact same thing. One is looking at less than 2 pounds, one is looking at more than 2 pounds. So because of that, you know that they're both wrong because they're both saying the same thing. They're both inferring the same thing. Here, if approximately 30% of all fish in the pond weigh more than 2 pounds, that means that approximately 70% weigh less than 2 pounds, which would mean 70%, which is the majority, weigh less than 2 pounds. So these are A and C are saying the same thing, and therefore you can always conclude that they're wrong. And then the last one says 30% of all largemouth bass in the pond weigh more than 2 pounds. You just see that it's not generalizing it to all the fish. It's just amplifying the data like we did in the last two questions. So you can conclude that this one is most likely supported by the data. And then B, like we said, doesn't make any sense because of how averages work. So the answer has to be D. So this is one of the harder easy questions. I honestly don't know why they put it as easy question. Some of the medium questions that we're going to go. Sorry, this is sorry. This is a medium question. Oops, sorry. I thought it was an easy question. So then never mind about that. This one says that a park ranger asked a random sample of visitors how far they hiked during their visit. The estimated mean was found to be 4.5 miles. So just note that it's estimated. It might not be important. It might be. With an associate, so there's a margin of error of 0.5 miles. These are the following best conclusion from these data. So this one, let's first, actually, just read them one by one and see which one. makes the most sense. So this one says that it is likely that all visitors hike between 4 and 5 miles. That one same as option B. If you know how the average mean is average, so if you know how averages and means work, just because the mean is 4.5, that does not even mean that does not mean that most visitors hiked around 4.5 miles. You could have had like 20 visitors hike like let's say 3 miles, or yeah, let's say 20 visitors hiked 3 miles, and then the other 20 hiked 6 miles. So none of that is close to 4.5, but the mean is 4.5. The mean here is 4.5, but none of the visitors actually hiked around 4.5. So that is an example of how the data could be, which is why we can eliminate B. And then it's like hike between 4 and 5 miles. This one we said based on the averages definition. And so the first two are both based on the definition of the mean, the definition of what an average is. C says that it is not possible that any hiker hike less than 3 miles. Same reasoning as above. This is the mean. Some like we could have had 10 people hike 0.5 miles, and like 30 people hike 7 miles, and the average I'm not going to calculate, but the average would be like around 4 to 5 miles. So this one is also wrong. So like the first three, you can literally just eliminate it based on definition of mean. Definition of mean eliminates the first three. And then D says, and again, you could see that again, like I said last time, A and B almost say the exact same thing. So you can infer that both of them are going to be wrong. This one said that most visitors hiked between 4 and 5 miles. This says that most visitors hiked exactly. This is more extreme. And almost every time on the SAT, if something is extreme, in both the ELA and the math portion, if it says exactly or every time must or something like that, it's almost always going to be wrong on the SAT. And then D says it is possible that the mean distance hiked for all visitors is between 4 and 5 miles. So, what is the definition of the margin of error? The margin of error is basically plus or minus. So 4.5 plus zero point 0.5 is going to be 5. 4.5 minus zero point 0.5 is going to be 4. So it is likely that the estimated mean can vary between 4 and 5, which is the definition of the margin, is how you can use the margin of error, which is what D is doing. D is just using the margin of error to conclude that the mean distance can be between 4 and 5 miles, which is correct. So that is it for the medium questions. Let's move on to the hard questions. This is one of the ones that have a chart. So this one says a researcher interviewed 411 U.S. residents. He asked them about their views on the use of nuclear energy. That's not important. And the table summarizes the data. The population of the United States was 300 million. So this is telling us the total. So I'm assuming there's going to be some amplification or like generalizing the data. Based on the sample data for the 411 residents, yeah, what is the best estimate in millions of the difference between? So they want a difference. So we're gonna have to generalize it, but then we're still going to have to calculate a difference. So what is the difference between U.S. residents who somewhat favor or strongly favor the U.S. nuclear energy and the number of residents who somewhat oppose or strongly oppose? So basically, what we're going to do this. So we're going to find the difference between those who strongly favor, somewhat favor, minus somewhat oppose, strongly oppose. So we're going to find the difference. So what do we start with? First, we have to amplify the data. So this is based on 411 U.S. residents. So first thing, let's see how many people. We're just going to generalize it into two because it's generalizing. It wants the difference between those who favor and those who oppose. So 56 plus 214 is 270. So 270 of them favor. 270 favor. 270 favor. And then how many oppose? 104 plus 37 is 141. 141. So 41 people oppose. And that is from the initial what? That is from the sample size of 411 residents. And remember we're assuming that the population of the United States is 300 million. So now what we do, everything we can do is in the calculator. So what do? Basically, First thing, let's amplify the data so we can get the numbers. So let's find those who favor. So out of those who favor, so we have 270, and I'm just going to use a fraction. So 270 out of 411, and 141 out of 411. So like here, like if you prefer a percentage or decimal, you could do that. But a fraction, you literally just type it. Like if you wanted to find the decimal here, you would have to type it in, find the decimal, then multiply. It's just a waste of time. So almost if you don't prefer anything else, or if you don't care, just use the fraction always. So 270 divided by 411. So that is the fraction who favor from the total. We're going to multiply that by 300 million. But then it tells us that they want the answers in millions, so we can just multiply it by 300. So that it's not confusing. Because basically the answer is going to be, if the answer is 3 million, you only put 3. So we're just going to multiply it by 300 million because they want the answer in millions. So 197 people favor, 197 million Americans, citizens of the United States, favor, what is it? Favor the use of nuclear energy. So how many then oppose it? 200, sorry, not 270, 141, same thing, divided by 411, times 300, 102.919 favorite. Also, always make sure that you don't round until the end. So right here, you might want to do 192 minus 103. Right in this question, I don't think it's going to make a difference. In some questions, it might. So always leave the rounding till the end. Then you just get it wants the difference between those who favor and those who oppose. So we're going to take that 197, and we're going to subtract 102. On the SAT, I don't think copy pasting works. So you're gonna have to just write the first few digits, like 0.08029 or something, 0.8029. Just write it out like that. Like make it like a rule of thumb. Just use 5 decimals or something, 4 or 5 decimals. But here we can copy paste because it's not on the SAT. We get 94.16. So 94.16 is the difference. 0.16. 161, let's say. 0.161. Let me just make it look better. Okay. 94.161. 94.161 is the difference between those who favor and those who oppose. So then if you type that in, you're going to get it wrong because what does the question say? Round your answer to the nearest whole number. So rounding it to the nearest whole number, you get actually 94, and that would be the correct answer, 94. If you don't round, they're going to give you the wrong answer. So 94 million people is the difference between those who favor, those who oppose. That is how you solve that question. So that is it for this video for how to do inferences from sample statistics and margin of error. So as usual, if you have any questions or anything you want to just say, let me know in the comments. If you want a video, just let me know in the comments. I'll make sure to make it. Um, after this, we have one more video for problem solving and data analysis. Then we're going to move on to geometry, where there's 4 videos, and then we'll be done with SAT Math Explained series. And yeah, that's it. So thank you guys for watching. If you could, um, please consider subscribing, liking, clicking the bell, and sharing. So that would help support my channel. Thank you for watching, and bye.